Hello class, welcome to this lesson, which is lesson 2.4, factorization of general trinomial of second degree. And once again, I know that you know how to do this. Sorry about the grammar. I know that you know how to do this from junior high because this is a technique that is taught in that period. And let's get down to business, right? I'm going to show you two examples of how to factorize a general trinomial of second degree. And first, let's talk a little bit of this name, right? General trinomial of second degree. What is the difference between this type of trinomial and something such as the perfect square trinomial? I mean, both are talking about trinomials, right? What is the difference? Well, the difference is that this is a more, let's say, more bounded or more bounded or restricted type of trinomial. This has to be necessarily coming from, as you know by now, the squaring of a binomial. What you get in here, that's a perfect square trinomial, and only in that case. But things like this and like this are not perfect, even though they are trinomials and they are of second degree because of this, right? They are not perfect square trinomials because if you run the tests that I showed you, those two steps for knowing whether they are perfect square trinomials, it's gonna fail, and you're gonna see that these are not perfect square trinomials. Nevertheless, they are trinomials of second degree, and when that happens, we just give them the name of general trinomials of second degree. By the way, is a perfect square trinomial also a general trinomial of second degree? Yes. Yes. You can visualize this idea by this diagram. In here we have all the general trinomials of second degree. All of them live in here. And the perfect square trinomials is a subset. Is a subset of this greater family, so to speak. So that's how you can understand the relationship between a general trinomial of second degree and a perfect square trinomial. That is, if a trinomial is a perfect square trinomial, it's also a general trinomial of second degree. But if another trinomial is only in this region, then it can be this type, but not this type, because this one is not living inside this region, so to speak. I guess you understand what I mean by this. This is what classification means. Some things are inside other more general things, more general classifications. Okay, too much talk. So let's get down to business, guys. In here we have two general trinomials of second degree, and what we want to do is this. We want to find two binomials, one here, such that their multiplication gives you in the end the trinomial that you started with. It's that simple. So one binomial here, one binomial here. As we know, a binomial consists of two terms, same here. And the general idea, the basic idea is this. You're gonna find two numbers, this one and this one, such that their multiplication gives you the first term in the trinomial. In this case, we have no other option but x and x. When you have no other option other than a single one, the factorization is quite simple. So x times x gives you x squared. And then you're going to have to find another two numbers, and you're going to put them here with their corresponding signs, such that their multiplication gives you the last term in the trinomial, which is plus 4. So what could those numbers be? Well, they can be 1 and 4, 1 and 4, or 2 and 2. Both options gives you plus 4 as their multiplication. Now, since I already know the answer, I'm going to go with the correct one, correct possibility, which is plus 1 and plus 4. Okay, if you notice, plus 1 times plus 4 gives you plus 4, And apparently you already have the answer down, which is x plus 1 times x plus 4. How do you check whether this is correct? Well, all you need to do now is the following. You need to multiply these two numbers. You're going to get 4x, and you need to multiply these two numbers, the ones in the middle. You're going to get x. You need to add them, 5x. And if this number coincides with this term in the middle, then you know that you got the final correct factorization. This is indeed the factorization of this general trinomial of second degree, and you can multiply it in order to really see that in fact you get this result. So that's how it works. Factorization, guys, in this case, well, in all cases actually, factorization is pretty much a guess game. You need to be, putting here combinations of numbers until you eventually get down to the final solution, right? That's how it works. It's a guess game, and with enough practice, you can see pretty quickly the solution in your head before you even, do any confirmation or anything. With enough practice. Let's do the next one. This is example number 6 from the workbook. 9x squared plus 21x plus 10. So once again, we open up parentheses, two of them, and I need to insert a binomial here and a binomial here by pure guessing. This number times this number should give me this. This times this should give me this. And when I multiply outer times outer plus inner times inner, I repeat, outer times outer plus inner times inner, that operation should give me 21x. That's how it works. So let's see. I'm gonna give you a wrong example first so you can see how you can get it wrong the first time but maybe correct the second time. So for example, let's produce 9x squared. I can produce it in such way: 9x times x, right? This times this, it gives me this. And then in order to produce plus 10, I can go with plus 5 and plus 2. Plus 5 times plus 2 is going to give me 10. But then I realize that when I multiply these two numbers, I get 18x plus the multiplication of these two gives me 5x. And when you add these two terms, you get 23x, which is not the one in the middle. So now you know that this factorization is wrong. And you need to start again. You need to erase these numbers and find another combination. What about 3x and 3x? This times this gives me also 9x squared. And for 10, let's keep 5 and 2. Let's see if this one works. So let's see. Is the multiplication of these two numbers, which is 6x, plus the multiplication of these two, which is 15x, right? How much is this? 21x, which coincides with this term in the middle. Therefore, I know that this is indeed my correct factorization. And you can confirm by actually multiplying these two binomials and going back to the original trinomial. So that's how it works, guys. That's how it works. Just pay attention to the signs of these two terms. This one and well, I mean, pay attention to all the signs, because the signs play an essential role in here. That they can be negative every now and then. You see, so it's just important. It's important. Let's see if you can get them done. All of these ones right here. All of this. Let's see if you can get them done just with this short lesson. And if you have questions, you can ask me in class. But that's about it. So it's 15. I have already done 2. Continue with the rest of them, and we can check the answers in a moment. Thank you, guys.